It is a formula we need to use of perpetuity. So the formula of perpetuity should be used because here the time period is forever. The annuity immediate is given by a formula P is equal to A into 1 plus I whole power n minus 1 divided by I into 1 plus I whole to the power n plus d. So if it is compounded 3 times in a year, 4 times in a year or semi-annually, then we should use the formula of effective rate of interest by replacing I with R. Hello everyone, a warm welcome to one and all. This is Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. Today in this session, we are going to discuss about the perpetuity as well as the deferred annuity. Now, in our previous session, we have taken the problems on the future value and the present value of an annuity due as well as annuity immediate. So here we have a concept called perpetuity. So what is this? So this is an annuity which is payable forever, that is infinite number of years. It is called as perpetuity. So perpetuity is an annuity whose payments continue forever. So therefore here it doesn't have any future value, but the present value of perpetuity can be formed by the formula P infinity is equal to A divided by I. So here infinity refers the amount which is payable forever. So now let us take the problems on perpetuity. So find the present value of a perpetuity of 3000 to be received forever at 4% per annum. So here the formula is P infinity is equal to A by I. So which is equal to 3000 divided by I is 4%, which is 0.04. We know that I should be always expressed in terms of decimal form. So therefore when you divide the value here, the amount is 75,000. So the present value of an amount which is paid forever is 75,000. Next question. A person endows a bed in a hospital at the cost of 7,000 per annum. If the interest rate is 14% per annum, how much should he provide in perpetuity? So it's the same again. So P infinity is equal to A divided by I. So which is 7,000 divided by 0.14 because it is 14%. And when you divide this, you will get 50,000 here in terms of rupees. So thus the perpetuity doesn't have any future value. It does have only the present value for an investment. The next thing is we have a deferred annuity. So what is this deferred annuity? So annuity is nothing but the equal installment. So deferred means here it is delayed. So let us see what do you mean by deferred annuity. A deferred annuity is an annuity in which the periodic payments start only after a certain specified period equivalent to a certain number of payment period. For instance, consider a person has taken a loan of rupees 30 lakhs from an employer. So initially he'll not pay the loan for the 2 years. He'll start paying the loan at the beginning of the 3rd year. That means for the first 2 years, he has not paid any equal installment for the loan he has taken. So that term or that time period which is delayed of paying the installment is nothing but the deferred annuity. So in such cases, if the annuity is deferred for n years, the first payment will become due at the end of n plus 1th year in the annuity immediate. So in such case, the annuity immediate is given by a formula P is equal to A into 1 plus I whole power n minus 1 divided by I into 1 plus I whole to the power n plus d. So this is the formula for a present value of an annuity immediate. So here the power is raised to plus d. So here d indicates the annuity deferred in n years. For example, if d is 2 years, then we will write it in the form of n plus 2. So the same present value formula in case of annuity immediate is replaced in the denominator in the form of 1 plus I whole to the power n plus d. Now let us take a problems on deferred annuity. A person purchases a house for rupees 25 lakhs with 5 lakhs as down payment. The rest of the amount he loans from a bank which offers 16% per annum compound interest and has to repay the loan in 20 equal annual installment. If the first installment is paid at the end of the 3rd year, find how much he has to pay each year. So here the person has taken a house of 25 lakhs. So he has made a down payment of 5 lakhs, and for the remaining 20 lakhs, he has taken a loan from a bank. So the rate of interest charged by the bank is 16%, which is 0.16. So he starts paying the equal investment at the end of the third year. So that means here the number of years delayed for 2 years. Now we need to calculate how much amount he has to pay each year, because it is paid at 20 equal annual installments. So that means the number of installment is equal to 20 here. So now here the present value is 25 lakh minus 5 lakh, which is equal to 20 lakh. So I need to calculate the equal installment, that is the annuity. So we will use the formula P is equal to A into 1 plus I whole to the power n minus 1 whole divided by I into 1 plus I whole to the power n plus d. So the value here A becomes P into I into 1 plus I whole to the power n plus d whole divided by 1 plus I whole to the power n minus 1. Now let us substitute the values here. Then A is equal to 20 lakhs into I into 1 plus I whole to the power n plus d. So that is here 20 plus 2, which is 22 whole divided by 1 plus I again 1.16 whole to the power 20 minus 1. So now the value here is 20 lakhs into 0.16 into 1.16 whole to the power 22 whole divided by 1.16 whole to the power 20 minus 1. So solving the numerator value, we will get the value 8379467 divided by 18.46. Again dividing these two numbers, we will get the value 453,935.37. That is 4,53,935.37 is the required annuity. Next question. What is the present value of an annuity of 6,000 payable from the end of the 11th year and for 15 years thereafter? The interest rate is 9% per annum. Now we need to calculate the present value. So annuity is given, that is rupees 6,000. So it is not paid for the 10 years. So that means deferred time is 10. So it starts from the 11th year and 15 years thereafter. So therefore number of installment is 15 and the interest charged is 0.09. So therefore present value of a deferred annuity is A into 1 plus I whole to the power n minus 1 whole divided by I into 1 plus I whole to the power n plus d. This is equal to 6,000 into 1 plus 0.09 whole to the power 15 minus 1 whole divided by 0.09 into 1 plus 0.09 whole to the power 15 plus 10. Now this is equal to 6,000 into 1.09 whole to the power 15 minus 1 whole divided by 0.09 into 1.09 whole to the power 25. So this is equal to 15,854.89 whole divided by 0.7760. Now dividing these two numbers, the present value will be equal to 20,431.55 in terms of rupees. Next question. What is the present value of an perpetuity of 5,000 to be received forever if the first receipt occurs at the end of the 6th years from now, interest rate being 8% per annum? So here the amount to be received forever. So that means it is a formula we need to use of perpetuity. So the formula of perpetuity should be used because here the time period is forever. So A divided by I into 1 plus I whole to the power D. Now the value of A is 5000. The value of I is interest rate is 0.08 and 1 plus 0.08 whole to the power. And we need to calculate D. See, the statement says the receipt occurs at the end of the 6th year. That means it is delayed for 5 years. So therefore this is equal to 5000 divided by 0.08 into 1.08 whole to the power 5. So dividing these values, I'll get the value 42,536.4 in terms of rupees. So this is the present value of a annuity 5000 which is received forever. So thus we have discussed about the annuities of immediate, annuity due as well as the perpetuity and the deferred annuity. So here let us recall all the formulas one by one. So whenever I'm talking about the annuity immediate, so annuity immediate is nothing but an equal installment which is paid at the end of the time interval. So here the future value formula is A into 1 plus I whole to the power n minus 1 divided by I. Whereas the present value formula is given by A into 1 plus I whole to the power n minus 1 divided by I into 1 plus I whole to the power n. Next we talk about the annuity due here. So annuity due means it is the equal installment paid at the beginning of the year. So here the future value is given by A into 1 plus I whole to the power n minus 1 divided by I into 1 plus I. And the present value is given by A into 1 plus I whole to the power n minus 1 whole divided by I into 1 plus I whole to the power n into 1 plus I. Next we have a perpetuity. So perpetuity doesn't have its future value. So therefore it has only the present value and the present value is given by A divided by I. Next is the deferred annuity. So deferred annuity is annuity immediate. So therefore P is equal to A into 1 plus I whole to the power n minus 1 whole divided by I into 1 plus I whole to the power n plus D. So in all these formulas, F represents the future value, P represents the present value. So again, the present value is nothing but the amount obtained or the lump sum amount obtained earlier and the installments will be paid later. So future value is nothing but the lump sum amount which is obtained later with the equal installment which is paid earlier. So again, A represents the annuity or the equal installment, I represents the rate of interest in decimal and N represents the number of installment. So whenever interest is compounded annually, so we can use I in the same way. So if it is compounded 3 times in a year, 4 times in a year or semi-annually, then we should use the formula of effective rate of interest by replacing I with R. Today we have discussed about the problems related to the perpetuity and deferred annuity. I'll meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.